Welcome everyone at NLP Summit. Thank you for having me here, and I'm pretty excited to share some development on NLSQL side in terms of natural language processing and natural language understanding. My name is Denis. I am CEO of NLSQL, company based in England, and my team consists of multidisciplinary professionals from AI, machine learning, technical side, as well as real, basically doctors who has real experience with the patient, with the treatment of patients. Basically, we did a couple of pretty excited projects and learn a lot from them. One of these projects is supporting Aachen Uniclinic uh, for making data more accessible for like intensive care unit databases, patients record accessible in different areas in Germany because of the vision of German policy and German new politics that all the databases in Germany have to be soon standardized in order to get ability to access the same patient information from different regions in Germany. That was excited project with Aachen Uniclinic, and we helped them to build AI interface to intensive care unit databases in order physicians or clinicians or head of departments have ability to quickly receive patient data analytics. Another project which we are really proud on, this is a recent research and development project together with Innovate UK here in England. We developed AI tool which helps empowering physicians with intuitive AI interface working on top of the poorly accessible clinical data to inform and accelerate clinical decision-making processes. So basically, let's get back to my slides. And so I will start from the early beginning so you can better understand the problem we are trying to solve and the approach which we are going to present here and how from the technology perspective we are solving this problem. So basically our mission as a company to solve a data analytics bottleneck problem between technical and non-technical employees, physicians and head of departments as non-data skilled employees lacks data accessibility. First of all, they don't have access to the databases, and they don't have access to the databases because they're not technically skilled enough in order to to create SQL and execute this SQL on top of the database. So basically, SQL analytics is very complex for non-technical employees. They have limited accessibility. Even if you can provide them database access, it will be useless for them because they don't have enough skills to use this, access to the database. Same as it will be really time consuming for them to retrieve data, even if they can have basic SQL. Nevertheless, they have to execute, then copy all the data to the Excel spreadsheet, and then start doing data analytics within the Excel, which for the non-technical employees is not super convenient to do and super fast. Also, one part of our challenge, this is a dirty data which exists already in most of electronic healthcare record systems, and sometimes there are some missing data or some inaccurate data, and so our system is also knows how to deal with with the dirty data in your databases. Basically, so many data, very limited amount of data skilled employees, and a lot of head of departments, physicians who are not data skilled enough in order to mine those data and insights from a lot of patient records. Basically, what is our approach? Our approach, it is hybrid, um, from vector database of which is including metadata embeddings with other model. We store all this metadata. So for the metadata, I mean like diagnosis names, prescription names, everything, all basically text format information from the healthcare database, which we can store on our database. And when we are doing natural language understanding, we trying to compare what we have in end user's question, comparing with the sinus similarity to what we have in our database. So in case some small typos or some very close meaning, we can detect those values from the metadata and present and actually understand the end user's question better. Also, we are using such quite powerful natural language processing methods like intent detection and slot filling. So for intent detection, we are using large language model, same as slot filling. For intent detection, you probably have a lot of different intents within your use case on top of the patient records, and all of these calculations, in our logic we call it intents, and you have a list of these intents. So if you're asking about who is Justin Bieber, like a global AI knowledge base, our system will not help the end users to ask this question. Of course, if Justin Bieber is not the patient for your hospital. But nevertheless, intent detection, we fine tune open large language model in order to detect intent from the end user question, because end users can ask the same question in a lot of multiple like options and variants. So it will help you also to detect the proper intent and get the proper calculation for the end users based on their natural language question. Similar for the slot filling. So as far as we all know, most of the database engines, they do need the specific data format, and they work only with a specific data format. So with the slot filling, large language model helps us to, first of all, to detect let's say period intent, and transform this period intent into the proper format which will be suitable for SQL interface on top of your database. Yeah, and basically we are using on our backend something called hybrid system, together with vector database as well as structured database. And our model works both with both databases at the same time, in order to transform natural language question to the structured query language code. Yeah, so basically that's our approach, how we are doing this very hybrid. We're using the specific technology to solve the specific needs on our on our algorithm, in order to help non-technical healthcare employees to have intuitive AI interface to the databases. Basically, what what our mission is to empower them with this chat interface, so they can get health patient healthcare records data analytics much faster. Yeah, so how it basically works. NLSQL enhanced data analytics accessibility for clinician by providing comprehensive bird's eye view on top of all the data you have. Those bird's eye view can be accessed through reports, data visualizations, or just the whole questions. Bird's eye view on top of all EHR systems records, it's quite important, as you might have only this interface, because a lot of questions, ad hoc questions, which is very different from one user to another one, from one use case to another one. So basically you get bird's eye view on top of the data, as well as you can ask very ad hoc and specific questions for some specific things. So for example, you can build a scatter chart for Daring cases by age, let's say. In case anything is not the, clear enough, the system will ask additional questions. This is one of the most important features of our model, that our model are able to ask additional questions in case of any ambiguities detected in end users' questions. In that case, of course, it is a question about, because we have Darin as a reader, as a patient, and two different patients with different, I guess, surnames. Yeah, basically, once all these additional questions responded by the end users, so we can generate a proper and accurate structure query language code in order to build either data visualization or calculation report. So here the brief sample of surgery cases analytics. So you can ask, like, show me a bar chart with a number of cases by readers this year, and basically everything is clear, so system understand everything and can build your data visualization. For some cases we have developed surgery duration analytics. For the surgery duration analytics, it's quite very important, especially for surgery clinics, in order to understand the start date, end date, average time for the surgery per surgeon, per reader, per hospital, whatever. And you can compare and benchmark all these indicators related to average pro time for the specific hospitals, surgeries, and readers. In that particular case, this is example how user can ask what are the top 6 hospital for the largest average reader time for the spine surgery. And yes, the system understand everything, basically no additional questions at this time. And the system creates structure query language code which sorts based on the average pro time and in minutes, and just limit with the top 6 hospitals, and providing the small table just within the end user interface to head of department or to physician. In case those tables is quite big, we have like kind of limitation, more than, let's say, 10 rows. We just generate an Excel file and send this Excel file with a link, so the end user can ask question like, show me average touch time per day by readers this weeks. So obviously there are a lot of readers and it will be more than 10 rows. It's not so easy to make data analytics within everything within the single chat interface. However, you can open this report and dig deeper in with your computer. Then another quite important feature which we detected from our research and development project with Innovate UK. This is the kind of information which is badly needed, especially for the physicians. This is kind of downstream complication calculation, the most common downstream complications calculation for the patients with multiple chronic diseases, but basically with the multiple conditions. So it can be easily done on top of intensive care unit database with NLSQL and natural language query capabilities. When physicians can ask a question like, just one moment, I will show you just once again. So the question was like, what is the most common 7 downstream complications for the male patients with Pseudomonas aeruginosa. So basically, yeah, there are a lot of options. So a couple more additional questions. Because the medical terminology is so complex, as the same word can have different meanings in different departments, let's say. And so every time the system keeps asking additional questions, something is not clear. So based on those questions, but you are not limited only like with a male, female, bacteria infection. You can use any period of the stay in intensive care unit, in emergency room admit. You can use different prescriptions which those patient has. And what is the main idea? To calculate based on your patient history, based on the hospital patient history, calculate the common patients with the same conditions in the past, and just to provide valuable information to the physicians about the top 7 downstream complications for this specific patient they treat just right now. This information can help physicians either to avoid or mitigate potential downstream complication. So, for example, those patient has some kind of surgery, and he stays, or he or she stays in the hospital for 2 weeks. And based on calculation, we know that those bacteria will be the most probable downstream complication for such hospital stay and surgery type, let's say. And in that case, physician can mitigate those downstream complication or avoid if make some other prescription to those patients. This timely alerts enable clinicians to prevent and mitigate complication quite fast, and it is real add value to their work, and that's which is ultimately improving the patient outcomes. So we are building enterprise ready software, so which is a bit complex in order to provide the full security, full data security, and capability to connect to the different data sources. So but basically, under those complex software architecture, we have basically API which can transform natural language questions to the structured query language code, and you are able to integrate those API whatever you want. Of course, we know that most of the hospitals, they asking about the on-premise solutions, and basically that's fine with us. It will be like a microservice on with the AI model on the back end, where you can basically ask question and get the responses using like microservice application within your hospital IT ecosystem. So again, so this is kind of approach to making AI data analytics accessible for non-technical employees with generating SQL every time, which which brings more and different responses to the user's fingertips. So this is basically what it looks like in the standard way, so the most common software architecture, but nevertheless, that's it for my side. I'm pretty sure I'm in time of 20 minutes. If you have any questions, feel free to contact us, and the best way to predict the future is to create it. So I hope let's create the future together.